Between the orbits of Mars and Jupiter lies one of the most intriguing and misunderstood regions of our solar system, the Asteroid Belt. Far from being an impenetrable wall of chaos, as often portrayed in science fiction, this vast expanse is a lonely graveyard, a cosmic reminder of what might have been. The asteroid belt contains millions of rocky bodies, ranging from pebbles to dwarf planets. At its heart are ancient objects like Ceres, the largest asteroid and officially classified as a dwarf planet, and Vesta, a uniquely differentiated body with signs of volcanic activity in its past. These objects are more than space rocks. They're fossils from the solar system's violent youth. But here's the mystery. Why didn't all this material become another planet? To answer that, we need to go back to the birth of the solar system. Around 4.5 billion years ago, a swirling disk of dust and gas surrounded the newborn sun. Through a process of accretion, particles began sticking together, forming planetesimals. Many of these merged to become planets: Mercury, Venus, Earth, and Mars. Yet in the region between Mars and Jupiter, something stopped that process. That something was Jupiter. As the largest planet in the solar system, Jupiter's immense gravity disrupted the delicate dance of planet formation. Its powerful pull stirred the region, preventing the building blocks in the belt from coalescing into a single body. Instead of forming a planet, the region remained a scattering of fragments, caught forever in orbit but never united. Over time, collisions between these fragments created the asteroids we see today. Some are solid rock, others are loose rubble piles held together by weak gravity. Their diversity is staggering: metallic, carbon-rich, icy, volcanic, and each type tells a different story about the solar system's evolution. Despite its name, the Asteroid Belt is mostly empty space. If you stood on an asteroid, chances are you wouldn't see another one nearby. The average distance between large asteroids is hundreds of thousands of kilometers. A spacecraft can pass through the belt without ever encountering a single object. Yet even from afar, the belt exerts profound influence. Some asteroids escape its boundaries, nudged by gravitational interactions or by the subtle but powerful Yarkovsky effect, where thermal radiation slowly alters an asteroid's orbit. Over millions of years, these drifters become near-Earth objects, and sometimes they intersect our planet's path. Other asteroids are pulled into orbital resonances with Jupiter, forming Kirkwood gaps, regions within the belt where asteroids are notably sparse due to these gravitational interactions. These gaps provide insights into the mechanics of orbital dynamics and chaos. The asteroid belt is also a laboratory. Missions like NASA's Dawn, which visited Vesta and Ceres, have provided unprecedented close-up data. On Ceres, scientists found evidence of cryovolcanism, ice volcanoes, and a possible subsurface ocean. This raises questions. Could such a body, once thought inert, support microbial life? Could it have done so in the past? These discoveries blur the lines between what we consider dead space and potentially habitable environments. Geochemically, asteroids in the belt contain elements vital for life and industry: iron, nickel, carbon, and water ice. Future missions may establish mining operations here, especially as humanity pushes toward Mars. The belt could serve as a pit stop or even a resource base for deep space travel. Yet for now, the asteroid belt remains mostly unexplored. We've studied only a fraction of its members, and each mission uncovers more questions than answers. At Infinity Beyond, we see the asteroid belt not as a static field of rocks, but as a dynamic archive of solar system history. These are the failed planets, the would-be worlds that never were. But in their failure, they became something equally valuable: messengers of deep time. Every cratered surface, every irregular spin, every spectral reading tells us more about how planets form, how they die, and what secrets they carry inside. Some asteroids may be as old as the solar system itself, never melted, never changed, preserving their original chemistry from the dawn of time. Others, like Vesta, show signs of geologic activity, differentiation, and surface evolution, hinting that they came close to becoming something more. In that way, the asteroid belt is not just a graveyard. It's a museum, a puzzle, and perhaps, one day, a gateway. Imagine a future where humanity builds research stations on Ceres, sends rovers from asteroid to asteroid, and harvests resources to power cities on Mars. The asteroid belt could become the backbone of our solar civilization, one stone at a time. So the next time you hear the words asteroid belt, don't think of it as space debris. Think of it as history in motion, silent, scattered, and eternal. Stay with Infinity Beyond as we journey further into this incredible region, where every orbit tells a story and every rock has a memory.